Hi guys, welcome to virtual learning. You people know the situation because of the coronavirus. We are supposed to complete our syllabus using the virtual learning techniques, and I have preferred to do this class in YouTube. So kindly follow up the notices sent through your class reps, because I can't come and tell you individually. This is particularly for you people, for Jyotinivas people, so that we can complete our astronomy syllabus. I know PMC have completely completed the syllabus, but whereas PCM and PME class are yet to finish this part called telescopes, which I'll be talking today. And once we are done, we will just go through, I'll just give you what are important stuff you have to study for your final exam, which is upcoming. And one important note is, like, there will be no extra classes once you start this when you come back to your college. There will be no more extra classes, so keep that point in mind and make sure you start preparing right now. And we will start today by talking about telescopes. I have given a brief introduction about telescopes in all the classes, and primarily we have two different types of telescopes. One is called refracting telescope and another one is called reflecting telescope. And you can see the diagram of a refractive telescope, and you can see there is an objective, there is a lens which is behaving as an eyepiece, and there is an objective which is supposed to gather the starlight. This is a primary objective, so the focus of everything comes to this point called capital F. What happens is, starlight, you know, light falls at different wavelengths, so they don't come in a uniform way, so they come at different wavelengths. Once they hit the objective, their focus actually falls in different places, and this is a big problem in astronomy because you can't have multiple focuses. So we need to have one focus, and this problem is called as chromatic aberration. So this aberration has to be corrected, and doing this correction there are different techniques like alignment and using multiple objectives and other things, where you can trap light to such a way that it all comes and falls into a single focus called F. So, you know, light is basically an electromagnetic wave, and it has different wavelengths, and due to different wavelengths, the probability of this aberration will be more. So in order to correct that, we can have those kind of alignments. Primarily, refracting telescope has an objective. The starlight enters this way, and you can see the image being formed here, and you can watch it through an eyepiece here. Okay, so this is how a refracting telescope looks like. And the disadvantages or the drawbacks of these refracting telescopes is it's very expensive to make, very hard to fabricate these lenses, and the lens usually are very overweight, and it's very hard to carry over mountain tops, where usually telescopes are used on the mountain tops. And we need to have a clear air and dark spaces. Like, dark places is very important. The reason is, dark places will help you to observe, because photon is the only information we get from sky. So we need to make sure that we don't lose any form of information. So in order to trap this information, what we do is, these photons have to be accounted for. So we have to make sure none of these photons are lost, none of these photons are gone away somewhere. So all these photons has to be captured, and this is captured and watched and recorded through a refracting telescope. And one more important reason why we need a we always say a reflecting telescope is better than a refracting telescope, and I will talk more in detail in the next video. About the entire video will be on reflecting telescope, and this video we will just compress everything to a refracting telescope. Once we learn about reflecting telescope, you can see the beautiful differences between them. And for any astronomical observation, the main key thing is you need to have clear skies, no clouds, there shouldn't be much of a light pollution. Light is one of the biggest enemy in astronomy, so I always keep telling this thing in the class, like we need to kill all the street lights, we need to start hitting stones to the street lights. So these are the things, but don't do that. So what I suggest you to do is, like, you go to a darker place, like where there is maybe like a forest kind of a place, or a sea, or a mountain top, all these places where humans have not exploited, and most of the places are actually exploited by light, but still we have some good places like Hawaii and Hawaii in United States, even Kavlur in India. Kavlur telescope is Asia's largest telescope, so it is one of the key thing to know about. So we have a very good telescope, and it's a reflecting telescope, which we will be talking about in the next video session. So this is all about refracting telescope. This is a very basic part of telescope when telescope was started. So refracting is for portable telescope. Nowadays you can get both refracting as well as reflecting telescope. These are portable telescopes, you can carry them wherever, like it depends on the diameter of the objective. So if you need a larger diameter, then you need to go for a larger telescope, and if you want a larger mirror in a reflecting telescope, which is a primary thing, so you will be needing much larger telescope. So it's a very huge task by itself. So this is the basic beginning of the refracting telescope. Thank you.